Hi everyone, I hope you all are doing good. So in my today's session, I'm going to discuss about the facade design pattern, one of the structural pattern. So let's start with it. Okay. So what is a facade design pattern? The facade is a software design pattern commonly used in object-oriented programming. Okay, it's analogous to a facade in architecture. A facade is an object that serves as a front-end facing interface masking more complex underlying or structural code. Okay, so that's all about the facade here. A facade can improve the readability and usability of a software library by masking interaction with more complex components behind a single API. Okay, so it's basically a kind of shelf, you can say, guys. Okay, or you can say a front facing interface. Okay, which basically hides a lot of inner complexities and provides a simple interface for the end users. Okay, so that's what they are saying. So provide a context specific interface to more generic functionality, okay, complete with the context specific input validation, serves as a launching point for a broader refactor of monolithic or tightly coupled systems in favor of more loosely coupled code. Okay, so it provides a context specific interface to more generic functionality. Okay, you have a hell lot of functionalities with you, but by using a facade pattern, basically you are providing a context specific interface. So it calls only some part of that generic functionality or the complex functionality and puts specific validation only for that part. Okay, and also as they said, serves as a launching point for a broader refactor of monolithic or tightly coupled systems in favor of more loosely coupled code. Okay, so also forms as a basis or a launching point in order to provide a refactoring for a monolithic or a tightly coupled system or existing system, or you can call a legacy system. Okay, so developers often use the facade design pattern when a system is very complex or difficult to understand because the system has many interdependent classes or because its source code is unavailable. This pattern hides the complexities of the larger system and provides a simpler interface to the client. It typically involves a single wrapper class that contains a set of members required by the client. Okay, these members access the system on behalf of the facade client and hide the implementation details. Okay, so overview, what problems can the facade design pattern solve? Okay, to make a complex subsystem easier to use, agreed, a simple interface should be provided for a set of interfaces in the subsystem. The dependencies on a subsystem should be minimized. Clients that access a complex subsystem directly refer to or depend on many different objects having different interfaces. Okay, which makes the clients hard to implement, change, test, and reuse. Okay, so these are some disadvantages if you have a legacy system which is very complex in nature. Okay, so you can't directly access all of its functionalities or it's very difficult. Okay, so that's why you need to adopt the facade pattern in order to allow the loosely coupling and make the system more easy to implement, change, test, and reuse. Okay, what solution does the facade design pattern describe? Okay, so it defines a facade object that implements a simple interface in terms of or by delegating to the interfaces in the subsystem. Okay, and may perform additional functionality before or after forwarding the request, which is most of the times validation, guys. So suppose the existing system, legacy system or a complex system doesn't have that validation. So what facade can do? Facade can perform the validation on behalf of that and forward the request to that legacy system. This enables to work through a facade object to minimize the dependencies on a subsystem. So a UML class diagram and a sequence diagram. Okay, so just see the class diagram, guys. Your client is going to use your facade. Okay, your client will make use of a loosely coupled a simpler interface called facade, but the facade will take the responsibility of invoking your subsystem or a complex system behind the scenes basically. Okay, so the facade is calling class 1, class 2, class 3 based on the request put by this particular client, and the sequence diagram or time diagram, you can say, basically if you see here, client makes a request to facade and facade will decide what subsystem to call or what class to call. Okay, so that's all about the diagrams. Okay, the facade pattern is typically used when a simple interface is required to access a complex system. Okay, A system is very complex or difficult to understand. Most of the times, guys, this pattern is used with the legacy software components or libraries, okay, which were designed almost a decade ago. They are very complex to understand. They are not up to date, but still the functionality is highly reusable. So these are the use cases where you will go with facade pattern. An entry point is needed to each level of layered software, or the abstractions and implementation of system are tightly coupled, okay. So in most of the time in modern softwares, we define the interfaces or contracts as abstractions, and then we create equivalent implementation in terms of classes. But uh, in legacy systems or complex systems where these things are tightly coupled, okay, they have not followed the concept of proper abstraction and implementation. In such systems, in such cases, we have to go with facade pattern, okay. So that's all about it, and move forward. Advantages of this pattern, as already explained. One of the main benefit of the facade pattern is that it reduces the coupling between different parts of a structural system, okay. Yes, so you are not required to tightly couple with the existing system, which is complex. So you will basically specify a lot of facades or simpler interfaces, which basically deal some part of the system as per the requirement by your client. Okay. So by encapsulating the logic and interactions of the subsystem behind a facade, you can isolate them from the rest of the system and avoid unwanted dependencies. Okay. So it also helps us to avoid unwanted dependencies. This makes it easier to change, test, and reuse the subsystems without affecting the facade or the clients that use it. Very important point. Okay, whenever some change happens in the existing system or a legacy system, okay, so if you are directly referring it through your clients, then it may result in making changes to your client codes also. But in order to avoid that, we can make use of this pattern, so that whatever changes happens in the existing system or the legacy system, it doesn't affect your client code directly, okay, because you have abstraction of your facade, okay. So it's completely the responsibility of the facade contract, okay, which is not going to change much from the client side. It will remain intact. Only thing, the subsystems which the facade invokes, those will change, so that shouldn't be creating any impact on the client side code basically. Another benefit of the facade pattern is that it simplifies the interface for the clients, agreed, by providing a single point of access and a consistent level of abstraction. Yeah, you can hide the complexity and details of the subsystems to make them easier to understand and use. Agreed, because by using the facade patterns or various facades in your system, you are basically making it very easier to understand. Okay, and also it will be very easy to implement further changes. This reduces the cognitive load and the risk of errors for the clients and improves the usability and readability of the system, which is already I explained. Well, disadvantages of this pattern. Yes, it can introduce a performance overhead by adding an extra layer of abstraction and the communication between the clients and the subsystems. You can increase the latency and the resource consumption of the system. I won't completely agree with this, because today's computing systems are very fast, they are powerful. So adding one more layer doesn't cost that much, guys. Okay, so I agreed there will be one more layer of abstraction, but I think with the modern technology, it's okay kind of for me. This can affect, let's go to the second point. This can affect the speed, efficiency, and scalability of the system, especially if the facade has to handle a lot of requests or data. Okay, well, kind of agree and disagree statement, but yeah, possibility, there is a possibility it can affect the efficiency and scalability of the system, but I don't agree with the speed basically, if the facade has to handle a lot of requests or data. Okay, it can limit the flexibility and customization for the of the clients. By hiding the details and options of the subsystem, you can restrict the control and choice of the clients over the functionality and behavior of the system. Yes, uh, I will agree with this particular point, because you are basically abstracting out, you are basically putting a constraint on the number of options or the number of features provided by that legacy system or a complex system. Okay, by using the facade, you are basically restricting the available options for the end clients. But guys, there is always a trade-off. Okay, if you want to achieve some advantage, always you have to pay for it. So That is what I agree here. Yes, there is one disadvantage where yes, I won't be able to have a complete features, I won't be able to access the complete features available by the clients. But by creating a set of facades, right guys, we can overcome with this particular disadvantage. And yes, we can resolve the problem by having functionality specific facades for existing subsystem. Okay, well, this can make it harder. Let's go to the next point. This can make it harder to adapt the system to different needs, preferences, and scenarios, and reduce the innovation and creativity of the clients. Okay. Yeah, I think it is harder to adapt the systems to different needs. Yes, because we are specifically created facades, so we specifically created some contracts which fills only some of the needs the client is expecting. But yes, in order to do the innovation, in order to have the creativity for the clients, I agree, I think there will be some lack basically, or a disadvantage associated with this pattern. So the point is that you want to make use of a set of features, or say maximum set of features, or the good features basically provided by the existing system. But because of a constraint which I am putting by using facades, I think there is a little drawback. There is a little disadvantage, or you can say a constraint on basically doing the innovation on the client side basically. Okay, so I agree with that. So these are the disadvantages. So let's go to a simple code example, guys. I will explain how this pattern works. A very trivial example, but it will make you people understand the core of this particular design pattern. So I have written a simple code, okay, a simple example where my hotel basically is a facade for me. Okay, my hotel, so day by day we will visit to hotel. Okay, and they have lot of options for us, like North Indian, South Indian, Chinese. Okay, lot of options are there. And when we put our order, right, whenever we place the order, we most of the time we won't place a order for any specific cuisine. Okay, we will mix and match. We put for North Indian, we put for South Indian, for Chinese. Okay, sometimes we mix and match. Okay, so let me explain how this thing will work now. Okay, so I have created a contract called iMeal, an interface. So meal will be there in North Indian as well as South Indian. So there will be two methods: get North Indian meal and South Indian meal, and a meal provider basically who provides the meal, so which implements this iMeal. And yes, the meal provider will provide both North Indian meal as well as South Indian meal. Same way, I will go to the breakfast. I have a contract called iBreakfast, and which will give me a North Indian as well as South Indian breakfast, and I have a breakfast provider. Okay, so which will fulfill my contract for providing the breakfast for both North Indian, South Indian by implementing these two methods. Okay, now see the class hotel facade. So our hotel is basically a facade here. Our hotel represents a facade pattern. Okay, so it has all the meal providers with it. See the contract being used, iMeal. I'm specifically using iMeal here, not a specific meal provider like North Indian or South Indian. Okay, so I have a iMeal, I have a breakfast, iBreakfast for the iBreakfast provider. And if you see when it is instantiated basically, okay, I am basically setting both of my meal providers, meal as well as breakfast providers. Okay, so now this particular hotel facade is giving a simplified interface to my complex subsystem, which is called this the meal provider basically, and then the breakfast provider. Okay, they are very complex basically. And then if there is a other variant, okay, there will be other kind of provider will also be available. But for the simplicity of this example, I have taken this example. Okay, now hotel facade, what it is going to do? Okay, it has a simplified interfaces. See, they get North Indian meal, get South Indian meal, get North Indian breakfast, South Indian breakfast. Okay. Now, when it comes to the client, okay, when it comes to the person who basically receives the order and executes all those orders from the customer, see what happens. A client order number 111, he ordered for a North Indian menu. Okay. So What I'm doing, he ordered for North Indian meal as well as North Indian breakfast. So using the facade pattern, I will order, I will request basically North Indian meal and North Indian breakfast. Now order number 112, he is interested only in South Indian menu items, so he ordered a South Indian meal and South Indian breakfast. So see, using the facade, only using the facade, I am basically uh, I'm requesting the meals. Okay, so I'm requesting a South Indian meal as well as breakfast. Now see the third scenario here, the client is interested in both north and south. So what he's doing, he is ordering both South Indian breakfast as well as North Indian breakfast. Okay, see, that's why, that's what I already explained. A facade basically acts as a simple interface for an underlying complex subsystem. Okay, I have a North Indian provider. Okay, I have a South Indian provider. If you see the code over here, see, I have a North Indian yeah, the breakfast provider. Okay, I have a meal provider, and if I have something else, any other cuisine, then I will be having the equivalent providers for that. So giving these classes basically, okay, giving these classes directly to the client is not favorable here. Okay, so what we did, we basically abstracted out all the complexities of my existing system into a facade which is called a hotel. Okay, a hotel facade, and it is completely the responsibility of this hotel facade to forward the request to the underlying subsystems, which is a meal provider or a breakfast provider, and internally that provider will take care of what meal to serve. Okay, now very simple interface. You are not required to worry about the providers who provide you the breakfast or meal. You just put your order on this facade and get your orders available on your table. That's it. So that's what we did here. We ordered a North Indian. Okay, we ordered only South Indians, and we ordered both mix and match. Okay, so if I run this program, so if you see the output, see, client order number 111, he was interested only in North Indian meal and breakfast, he got it. Client order number 112, he was only interested in South Indian, he got only South Indian. Whereas the client number 113, sorry, the client order 113, interested in both, he got both of the yeah, the meal as well, sorry, both of the breakfast in South and North variant are available to him. So that's all about the facade design pattern, guys. So as I already explained, it hides the underlying complexity of its existing subsystems. Okay, again, it also provides a loosely coupling between your existing system and your client code. My main is the client here basically, and you see, I'm not at all directly referencing any of my existing subsystem, which are the provider, meal and breakfast provider. Instead, I am achieving all my communication, okay, through this facade object or the facade contract basically, or the interface you can call a simplified facade interface. Okay, so I hope you people understood the concept of facade design pattern, and I hope you people will apply this in your day by day design activities. Thank you for listening and have a nice day.